Hi, this is the final lesson of Topic 10, Electricity and Circuits. And in this lesson, we're going to learn about electrical safety and how electrical safety has been embedded into our lives and into our homes. Now, we use electricity for everything, from charging our phones and laptops to heating our food using microwaves. And in each case, we use a plug and socket to connect to the mains electricity supply. Now, if we take a closer look at a plug, we can see that the pins are made of brass. That's because brass conducts electricity very well and it's extremely resistant to rust. If we were to cut open this plug along this point here, it would look a little something like this. Within the plug, there are three main wires and another component here. We're going to look at these in detail and understand how they impact electrical safety. For each wire has a specific use, a voltage, a color, and position. And the first one we need to consider is the live wire. That's the brown one on the right. The live wire is used to provide electricity from the main supply. It carries a voltage of 230 volts, and it's brown in color, and it's on the right. Next, we have the neutral wire. This wire carries current away from the circuit. So current flows from the live wire through the appliance, perhaps a bulb or your phone, and comes out of the neutral wire. It has a voltage of 0 volts because all the energy, all the voltage would have been used up by the appliance. And it's blue in color, and it's on the left. Now, there are several safety mechanisms which have been built into the electricity provision in the UK, and that's because electrical appliances can be unsafe. And this often results in electrical fires, as we can see here. The reason why electricity can be so dangerous is because the voltage, the energy per charge in the UK, is 230 volts. This can be very dangerous and it can actually kill you. So how do we actually stay safe when using electricity? There are three main things we're going to learn about. The first is the earth wire. Let's go back to our diagram of the plug. The earth wire is the one we haven't spoken about yet. It's this one right here, the green and yellow striped one. The earth wire carries massive amounts of current directly to the earth. This prevents large amounts of current coming into contact with us and harming us. It often looks like this. A large metal pole directly attached to the earth. So the electricity flows through this wire and directly into the earth. So the earth wire removes dangerous levels of current if there's a fault with an appliance. It carries 0 voltage normally. It's striped, as you can see here, and it's found at the top. Next, we have what's known as a circuit breaker. It's this appliance here that you've probably seen in your house. We all have them, and they're used in all modern houses. Circuit breakers detect the current flowing in and out of a circuit, and if there are surges in current, they automatically switch off like we can see here. So initially, current will be flowing through this circuit, as you can see here, and they'll automatically switch off if there's a surge, and they have to be manually switched back on. Finally, we have the fuse. The fuse is the last component of the plug that we haven't spoken about, and we can see it here. It's connected to the live wire, and up close it looks something like this. We often draw fuses in circuits using this symbol, and the line in the middle represents a thin metal wire. And this metal wire is actually designed to melt if the current in the circuit is too large. This breaks the circuit and prevents any more current flowing through it. This is due to the heating effect, as we saw in the last lesson. When the wire melts, current can no longer flow through it. that breaks the circuit and protects us from large current flows. Let's compare fuses and circuit breakers. Even though they serve a similar function, they are very different. Fuses, on the one hand, are extremely cheap. However, as you can see, once they melt, they can't be used again, they need to be replaced. Circuit breakers respond instantaneously and are more sensitive to surges in current. Unfortunately, they're more expensive to install and maintain. However, they are used in most modern buildings across the world. Furthermore, when using a fuse, the correct fuse needs to be installed. But what does that mean? A fuse should be rated slightly higher, but as near as possible to the current of an appliance. Let's see what that looks like in a question. An appliance has a power rating of 1500 watts and is plugged into the main supply. That's 230 volts. I have a 3 amp, 5 amp, 7 amp and 10 amp fuse available, but which should I use? Going back to the line at the top, a fuse should be rated slightly higher but as near as possible to the current of an appliance. So let's calculate the current flowing through this appliance. First, we're going to use the equation power equals voltage times current. In this case, we know that voltage is 230 volts and current is unknown, and power is 1500 watts. In this case, we can divide both sides by 230 and find that current is equal to 1500 watts divided by 230 volts. When we put that into our calculator, we find that current is equal to 6.5 amps. Therefore, for this current, I should use the 7 amp fuse. Here's another one. Read the question carefully, make sure you use the correct equation, and pause the video and have a go. So, in this question, we have a kettle that supplies 186,600 joules of energy during a time of 3 minutes. What rating fuse should be used for this kettle? So, in this case, we're going to use the equation energy is equal to voltage times current times time. The energy is 186,600 joules. My voltage, as it's connected to the main supply, is 230 volts. And current is unknown. And our time is 3 minutes. The first thing we need to do is convert minutes into seconds, because time should be measured in seconds. So our 3 minutes is actually 180 seconds. Next, we need to solve this equation for current. We're going to do that by dividing both sides by 230 and 180. That's 230 volts and 180 seconds. Therefore, our current will equal 186,300 joules divided by 230 volts times 180 seconds. We can put that into our calculator and find that current is equal to 4.5 amps. Therefore, our fuse should be rated slightly higher but as close as possible. So in this case, we need to use the 5 amp fuse. I hope this lesson and this series of lessons on electricity has been useful. If you have any questions, please do ask.